Okay, we're asked to solve this one, and we're going to solve this one via elimination. And the reason why we're going to solve this one via elimination, using elimination, is because neither one of these is solved for any variable, so a substitution wouldn't make sense. I'm not going to graph it. It's going to take more effort to try to put it in slope-intercept form to graph them than it would be just to use elimination. I can see right here that I have the same number on top and bottom, my twins, if you will. One of them's positive, one of them's negative, so we can just combine those two to cancel them out. The way that we're going to do that is we're simply going to add the two equations together. I don't need to change them at all because I can already eliminate my y's just by adding them where they're at. So here we go. My 3y minus 3y will just cancel each other. 4x plus 2x would give me 6x, and 16 and 8 would give me 24. Okay, so if 6x equals 24, divide both sides by 6, x would equal 4. Okay, so now that I've got my x value for this, my next step is I'm going to plug in 4 for x and find y. And I can use either one of these two equations. It really doesn't matter. I chose the first one just because it was listed first, but it will work. All I'm going to do, instead of writing x, I'm going to plug in 4 for x. So notice how it was 4 times x, now it's 4 times 4. And I'm going to simplify it and solve it. Okay, well 4 times 4 gives me 16 plus 3y equals 16. I need to get all of my constants on one side, so I'm going to subtract 16 from both sides. When I do that, I find out that 3y equals 0. I divide both sides by 3. Y is equal to 0. Well, now I have an x value and a y value. Because I have an x and a y, I can simply write it as an ordered pair, which will be 4, 0 using parentheses. Okay? And this is how you'll write it on the online system, just like that.